So far, we were discussing electromagnetic waves in vacuum or in free space, and we were deriving equations for the wave, energy density, momentum density, Poynting vector, etc. etc. Now we are considering electromagnetic waves traveling in matter or in some medium where there are no free charge or free current. So that means our rho, the density of charge, and J, the current density, both are 0. So we have the Maxwell's equations del dot D equal to 0, del cross E equal to minus dou B by dou T, del dot B equal to 0, del cross H equal to dou D by dou T. Okay, so these are the Maxwell's equations, and if we consider a linear medium, if the medium in which the wave is traveling is a linear, we know D is equal to epsilon E. Okay, the displacement, that is equal to epsilon E, and H is equal to 1 by mu B. So if we substitute for D and H in the Maxwell's equations, D and H in the Maxwell's equations, we will get the del dot E equal to 0, del cross E equal to minus dou B by dou T, del dot B equal to 0, and del cross B equal to mu epsilon dou E by dou T. Here we have put D equal to epsilon E and H equal to B by mu. So we get del cross B as mu go to the other side. We have del cross B equal to mu epsilon dou E by dou T. And we consider a homogeneous medium. Homogeneous means epsilon and mu do not vary from point to point. So everywhere in the medium, epsilon and mu are constant. So we are considering a linear homogeneous medium. Linear homogeneous medium. There the Maxwell's equations are given by these four equations: del dot E 0, del cross E minus dou B by dou T, del dot B 0, del cross B equal to mu epsilon dou E by dou T. Now these equations are different from the Maxwell's equations we saw in the free space, in empty space, just by mu 0 becoming mu and epsilon 0 becoming epsilon. Okay, so the only difference when we consider Maxwell's equations in medium is we have to replace mu 0 by mu, epsilon 0 by epsilon. Okay, so the velocity we will be getting, we have formed wave equations in the free space. The same way we can form wave equations here, and velocity, you know, that will be equal to 1 over epsilon mu. In free space it was 1 over epsilon 0 mu 0, 1 over root epsilon 0 mu 0. Here it is 1 over root epsilon mu. And we know the index of refraction, n, is equal to velocity in free space by velocity in medium. Okay, index of refraction n is velocity in free space divided by velocity in medium. So I can write V as equal to C by n, velocity in the medium. That is equal to 1 upon root epsilon mu. Okay, the index of n is the index of refraction. And we know C is equal to 1 over root epsilon 0 mu 0. So n is equal to C by V equal to root epsilon mu over epsilon 0 mu 0. Okay, now for most materials mu is equal to mu 0. Mu is equal to mu 0. For most materials mu is close to mu 0. Epsilon we know that is equal to epsilon 0 epsilon r. Epsilon r is the relative permittivity. So epsilon r is equal to epsilon by epsilon 0, or epsilon equal to epsilon 0 epsilon r. So n here for mu we substitute mu 0. Epsilon is epsilon 0 epsilon r. Epsilon 0 get cancelled, so we will get n equal to root epsilon r. Okay, n is equal to root epsilon r, and epsilon r is always greater than 1. Epsilon r is always greater than 1. That means n will be always greater than 1. Okay, epsilon r is greater than 1. So n will be greater than 1. So that means n equal to c by v. So v is equal to c by n. V is equal to c by n. N is greater than 1. That means the velocity n is greater than 1. So that means velocity of the electromagnetic wave in the medium is less than the velocity of light. So in the medium, the wave will be traveling slower than in the free space. Okay, so light travels more slowly through matter. Okay, since epsilon r is greater than 1. And our expressions for energy density will be simply half, instead of epsilon 0 we will have epsilon e square plus 1 by, instead of mu 0 we will have 1 by mu b square. So just replace epsilon 0 by epsilon, mu 0 by mu. Okay, so that is our u, and s, the Poynting vector will be 1 by mu e cross b. Okay, 1 by mu e cross b, that is the Poynting vector. And the intensity here now, the intensity is which is actually the magnitude of the Poynting vector, that is equal to half. Instead of c we will have v, the velocity in the medium, epsilon 0, instead of epsilon 0 we will have epsilon e 0 square. So this is the intensity. Okay, so these are the expressions, corresponding expressions in the media, in the medium. Okay.